Hey, Vlad here from devinsidy.com. Welcome to another video. As some of you might know, I'm a big fan of architecture and I wish I had the time to create an entire course on it, and maybe someday I will. Until then, you get to see glimpses of it. Today we're going to learn about a pattern which I like to call lower composition, which grants you freedom as a software developer at an arguably low price of some boilerplate. It's the implementation of the principle of least knowledge, also known as the Law of Demeter. Let's get right to it. Alright, now if you've seen one of my recent shorts about boilerplate, this is the video that I mentioned in there. By the way, everything that we'll do today will be uploaded to GitHub, so check out the link in the description box. Now, the idea for this video comes from an observation that I made a long time ago, which over time became a real pain. Whenever I dive into a new code base, whether it's for another job, or maybe I'm just helping somebody out, or I'm contributing to an open source project, which is something that I should do more often, by the way. In any case, whenever this happens, I get this claustrophobic feeling. I feel like I don't have enough space to put my code. I don't even know where to put it. I don't know how to call my classes because the names that I want to have are already taken. Sometimes I have a feeling that I have to directly depend on the modules that are already there and they don't fit my use case entirely. The technique that I will show you today will allow you to break free of these things and will make you feel as if you're contributing to a greenfield project. Now I need to be careful to not overpromise because this only works for projects that are at least a little bit prepared for this, or at least you need some buy-in from the rest of your team because some of the things that I will suggest are slightly controversial. As in most of my videos, I'm running Ubuntu 20.04 instead of WSL2 because I'm on Windows, and I'm also using Windows Virtual Desktop so I can go back to Windows like this and back to Ubuntu like that. So let's jump into some code, and since I need a bigger boat today, we're not going to start from scratch as we do in most of my videos. Now, what I want to show you today is how you can decouple two use cases from each other, even though one of them clearly depends on the other. To be fair, we won't be able to remove the coupling entirely. We will simply move it to another layer, and this will be good enough for us. The things that I will show you today are not specific to Scala. However, there are many Scala features that make this pattern extremely pleasant, especially in Scala 3. For instance, namespaces versus packages or the new export feature. Since I want to show you how to decouple two use cases from each other, we're going to start with one use case that is already made. And this is exactly the project that we did in the exports video. If you haven't seen it, don't worry, I'm going to walk you through the whole thing. So I'm currently in my dev folder and it contains a directory called Playground with the project from that video that I already mentioned. And so I'm going to open it with Visual Studio Code and walk you through the entire project. Let me just open it over here. There we go. What you see here is an SBT multi-build, and I like to use numbers for the directories of my projects to denote the layers of the dependency graph. As you can see, we have three layers. The first layer contains just the core, the third layer contains just the main, and then everything in between is on the second layer. It's usually the implementation details. I also have a dependency graph that I generated with Bloop, and it generates an SVG. So if I preview it, it looks like this. So I wish that it was flipped to the side, and then I would be able to say that there is a core at the bottom, which is why there is a 1. Then we have a bunch of these things that are on the layer 2, and we only have the main, which is on the layer 3. And as you can see, all the arrows point to core as it should be. I want to show you what is inside of these sub modules. However, before I do that, I want to actually do this while pointing at this dependency graph. So the core has two traits. The first one is called the boundary, and it also contains the implementation of this boundary. I usually choose this name because this is the boundary through which other things like the delivery layer of my application will access the core of my application. All right, so the trait boundary is in there. The implementation is also in there. Now, the implementation uses another trait, which I used to call entity gateway. These days, I actually renamed it to simply gate because it's shorter. Okay, so the core needs the gate. It access a bunch of things through the gate. The implementation of the gate is spread out through Google and storage in my case. What is inside of the delivery is the thing that I usually call controller. By the way, you can choose your own names, but all my use cases have a boundary, all my use cases have a gate, all my use cases have a controller. All right, so the controller simply accesses the core of the application through the boundary. It has no idea that its implementation needs Google or storage. It doesn't care about any of that. All right, and then we have the main that has access to all of these things. So the main has a thing called dependency graph, where it essentially assembles the controller, right? And in order to assemble the controller, it's the implementation of the controller inside of delivery, obviously, right? And the implementation will need the boundary, so it will know how to assemble the whole thing. So now let me actually show you the code. It is very important to understand that neither of these directories introduce a package with a similar name. So there's no package core, there's no package delivery, there's no package Google, there's no package storage, there's no package main, right? All of my packages are called dev.inside you, then the name of the application, which in this case is playground. And then inside of them, we have a directory for the use case and the package for the use case. In this case, I believe the use case is called comparison. And then inside of them, we have, if we're in core, we have the gate and we have the boundary. If we're in delivery, then we have the controller and so on. Okay, so if I open the core like this, we're going to have source, main, and then we have Scala dev inside you, then the name of the project, which is playground, then the name of my use case, which is comparison. Inside of it, we have the boundary and we have the gate. We also have the tests for the boundary, right? Also in comparison, boundary suite, test the boundary. So if I were to open all of these other projects, the directory structure would be exactly the same. And this is important, okay? So if I open delivery, for example, that uses the boundary, look, it's also in dev inside you, also in playground, it's also in comparison, and this is exactly how the package is also called. Inside of it, there is a controller that uses the boundary. If I open all of them, they will look exactly the same. Dev inside you, playground, comparison, Google, which is the implementation of this gate. We'll see the gate, we'll see why it's done like this. Open storage, exactly the same thing, storage, right? So these two together, they implement the gate that the boundary requires, and the boundary is required by the controller, okay? If we open the main, inside of it, we have exactly the same thing, playground, comparison. Inside of it, we have the dependency graph where this whole thing is assembled and the controller is returned. Then we have the main. Notice that the main is not inside of comparison because this is the one that will assemble all the existing dependency graphs, right? This is the one that takes all the already assembled use cases, puts them together, okay? In our case, we have only one use case, okay? So let's start with the main. If we go in there, right? Very simple application. It's in dev inside you playground. I prefer to use namespaces instead of packages. So we have comparison dot. This is also one important thing because there is only one place where we assemble all the use cases. There's no need to import them. You can just do comparison dot, dependency graph dot make run, right? So another use case would be other use case dot dependency graph dot make dot run. So if you go to the dependency graph, we're going to see that it assembles the controller. Controller needs the boundary. We're creating the boundary by giving it the gate. We're creating the gate by giving it the implementation for Google and the implementation for storage. We'll look into the controller. It's trivial, just a method called run, and the implementation over here, which requires the boundary. It simply implements run by simply doing print line boundary dot method call parameters. All right. If this was in the HTTP layer, instead of the print line, we would have HTTP routes. Now let's have a look at the boundary. Over here, again, simple thing, the definition of the method, and maybe let's create a little bit less space over here, like this. All right. So simple definition, simple implementation, boundary needs the gate. This is the implementation of the gate. Okay. In this particular case, it counts the pictures of cats in our case, and it also counts the pictures at Google. It updates the picture count and returns a Boolean, right? Whether what's on Google is greater than it's ours, which is why it's called, does Google have more pictures than the last time we checked? The gate is probably the most fascinating one. And in that video about exports, I pretty much said that I want my boundary to have only one dependency. So I put everything in the gate. Okay, so if we look at the gate, it's going to look slightly more involved, but essentially it's just a trait with methods. Okay, so if we look at the gate over here, right, it is just a trait which contains a couple of methods. It's just that they are inside of Google and storage. Google has these methods, storage has these methods. So the gate itself effectively becomes a facade, and the implementation of the gate simply uses the new export feature, right? If your language does not have the export feature, well, you simply have to write some boilerplate over here where you will delegate the methods. Let's do this real quick. So for example, let's say that your language does not have this. So we're simply going to delete this part, and then we're going to say override, and we're going to override this. Okay, so simply going to paste it like this, and the implementation is going to be google.count our pictures, right, off. Okay, so this is just a boilerplate that you need to write if your language does not have the export feature. Let me revert that stuff. There we go. Now, the reason that the gate is split into many things because the implementation of these things will require fundamentally different dependencies. For example, for talking to Google, we will need some sort of HTTP client. However, for talking to storage, we would need some sort of, I don't know, Postgres driver, if we're talking to Postgres and something like this. This is why they're in different submodules, right? So that storage over here can have, something like Doobie on the class path, and, so that Google has something like HTTP4S or SCTP or something like this on the class path, right? This is why they're separate. However, the implementation is trivial. Now, this is not the real implementation, of course, because this is just an education video. So if I click over there, this is simply a Google implementation. It's just a thing that creates a Google, and it simply does, 1000, right? Same thing for the storage. It pretends like it saves stuff, but it doesn't. It's just a unit. It counts the pictures like this. One of the main points of that exports video was the fact that my boundary can only have one dependency. This allows me to fake only one thing when I'm writing my test, which makes writing my test very convenient. So if I go in here at the very, very bottom, right? So I have 3 tests over here. At the very, very bottom, I have a fake gate, which basically just throws exceptions. And so over here, for example, in this particular test, I'm going to extend the fake gate and I'm only going to override the things that I need. So if we go in there, we're going to see, this is a bad example because I'm actually overriding all of them. But in a real application, you would sometimes override only a couple of them. So it's very, very trivial to write these tests because everything is fakeable and you need to fake only one thing, right? So you're controlling all of your inputs through one thing. Let me show you a couple of other tests since we're already here. This is another one. You can pause the video and have another look. And this is the first one, which is just a smoke test, I believe. All right, now that we're up to speed, let me close all the files and let me, well, actually, I'm not, like usually I like to collapse everything, but in this case, I'm not going to collapse. Okay, so we want to introduce another use case, which would have a dependency on this use case. Okay, so it will calculate some sort of report, right? So it will run it will call this method essentially, this one, for cats, for dogs, and for hamsters, for example, right? Just to have an example of a use case that depends on another use case. So in the beginning, we're going to do it, well, not exactly wrong, but not ideal. We're going to have a dependency straight on the other use case, okay? So we have a choice whether we put it inside of comparison because it's technically a report for comparison, or we're going to keep it flat and we're simply going to put it as a sibling of comparison. I always try to keep things flat, right? Only in some corner cases I nest things. Like nesting things, tends to be harder to reason about, okay? So we're going to go to a playground and we're going to create a new file, okay? We're going to call it report/boundary, right? Like this. As already mentioned in many of my videos, I prefer to use namespaces instead of packages, right? So I'm simply going to do this. All right, so we're going to have a trait boundary. By the way, in this video, we're not going to use tagless final or Z or anything like this, but the techniques that I'm going to show you work with those as well, okay? So we're going to call it same thing for all inputs, right? So this is going to be our report, okay? So it's going to return an option of a list of booleans, okay? So this is our boundary, we're done. All right, so let's do the implementation. So we're gonna have an object boundary and we're going to have a def make over here. It's going to require its own gate, which doesn't exist yet. And we're breaking my pattern where the boundary needs only one thing, but for now we're doing it wrong, okay? So it's going to require the boundary from comparison, right? Comparison boundary is going to be comparison dot boundary, okay? So, and it is going to return our boundary, okay? Like this. Okay, so we're going to do new, which is invert and Scala 3. Okay, so we're going to do override, and I'm simply going to steal it from here like this, join the lines like this, equals sign. All right, so we're going to have a use case that depends on some sort of configuration or some sort of feature flag. In our case, the feature flag in the end is going to be stored in Postgres, in a fake Postgres. It's not a real Postgres, but so we're simply going to use one of the factory methods on options. We're going to say option when, and we're going to do gate.is feature enabled like this. Again, the gate doesn't exist yet, but we're going to create it in just a second. Okay, so in this case, please create an option. Okay, so we're going to take a list of cats, and we're going to have dogs, and we're going to have hamsters like this. Okay, so simply going to take all of them and we're going to map them into comparison boundary dot, and the method is called, this one. Okay, there we go. So this is already the whole thing. Okay, so now we just need to create the gate. For now, I'm going to create the gate over here so that you see the whole thing. This is going to be the gate, and it needs this one. Okay, so no, not here. here. Okay, that is feature enabled, which is going to be a Boolean like this. Okay, so now this whole thing should compile. Now let's move the gate to its appropriate place. Oh, in fact, maybe actually Metals can do this for me. I'm not sure if it can do this in Scala 3. Oh, it can. Awesome. All right, great. So dev inside, you find a dot again like this, package, find a dot like this, package. There we go. It's already defined because this file is not saved. There we go. Awesome. Great. Cool. I didn't know that it works in Scala 3 already. Now we're going to split the gate already into storage, even though it's just one method. Okay, so what I'm going to do is I'm simply going to rename this to storage. Okay, and I'm going to go over here. I'm going to say trait gate extends storage like this. Okay, and I'm going to have an object gate over here, and I'm going to have a def make over here, and it's going to receive the storage as a parameter like this, storage like this. Okay, and it's going to produce a gate. And how is it going to do this? Well, it's going to create a new gate. How's it going to do this? Well, simply by exporting storage like this. As you can see, these details don't change anything for the boundary. The boundary just sees the gate. It doesn't care that it's split up into other things. In fact, we could even hide the storage entirely, right? We can make it package private, and we're actually going to have a tiny conversation about this by the end of this video. And since the boundary only sees the gate, you can freely move this feature flag, for example, to something like config, right? So for example, you could copy this, you could paste it over here, right? Just do this, find as, just do a config over here, remove it from here, right? And now simply do config over here, config, same thing over here, same thing over here, and same thing over here, right? And so you moved it to config, which I spelled incorrectly probably. Oh yeah, it's the fact that this trait does not contain any functions anymore, so I cannot use a colon in there. Okay, so now you kind of moved it to the config, right? And config is going to be a separate submodule over here. It's the one that is going to contain the dependency on the library that knows how to read the config. Okay, in our case, we don't need this, so I'm going to revert this whole thing until here. There we go. We're going to read the feature flag from storage. It's not going to be a real storage, but you get the point. All right, now following this thing, we're going to go and create a controller, right? So we're going to do a new file over here, and it's going to be in report/controller.scala like this. All right, find dot again and do package over here, find dot, do the same thing. There we go, package. Okay, so it's going to be a trait controller. And by the way, all of the controllers, they look exactly the same. So technically this could be factored out, and maybe we'll do this by the end of the video. Okay, so we're going to do object controller over here, right? It's going to have def make. It requires the boundary, right? Boundary. All my controllers look the same. All my gates look the same. All my boundaries look the same. Okay, it's a very, very convenient convention. Okay, so over here we're going to do new and override def run like this. Unit is going to be print line, boundary, same thing, auto completion. There we go, like this. As you can imagine, the controllers are very, very similar. In fact, as already mentioned, like these namespaces allow you to factor out something like this controller. Okay, so for example, I can go over here in playground, right? So it's going to be above comparison, above report over here, right? I can do new file controller.scala. Okay, it's simply going to be trait controller, right? Like this, def run, like, come on, like this, unit, like this. Okay, find the dot and do the package over here, right? And so now I can go over here into the comparison controller, and I can simply remove this. Notice that I don't need any imports. I don't need anything weird, right? So I'm simply going to do this. Okay, I wasn't actually planning on doing this today, but just looking at it, I realized that we could do this. Okay, very simple, no weird imports. Because we're using these namespaces, they can all see this controller. All right, so now we need the storage implementation. So again, we're going to go over here, right click, new file, report storage.scala. There we go. Again, find the dot as package, find another dot as package. There we go. So this is going to be a storage impl, and I would love to be able to call it storage, the same as the name of the trait. However, if I do that, it becomes a companion object, and the companion object has to live in the same compilation unit. It cannot be in a completely different submodule. Okay, this is why I still call the file storage, but the object storage implementation, which is a little bit controversial. Okay, but you can call it however you want. You just cannot call it exactly the same. Okay, storage implementation. Okay, so we're going to do lazy val make. Okay, it's going to be storage. It's going to be new, and we're going to do override def is feature enabled, which is a boolean. And instead of actually looking to the database, we're simply going to say true. Now let's do the dependency graph. And because the dependency graphs for me are always the same, I'm simply going to go over here. I'm going to create a folder this time. I'm going to call it report, okay, like this. And I'm simply going to copy this dependency graph. I'm going to paste it over here, okay. And all I need to do is I need to go over here. I need to change this to report. And in this case, we're not going to have Google, okay. And this should already be enough. This would have been enough if we were doing it correctly, but because I'm doing it incorrectly, we also need to provide the comparison boundary, okay? So over here, we're going to do comparison boundary, and we're going to say comparison dot dependency graph dot boundary, okay? So in this case, we actually need to go there and we need to split out the make so that we actually have access to this boundary thing, because right now it looks exactly the same as over here, right? So it has the lazy val make, it has the control and make. In fact, what we probably should do is I'm going to close all the others and I'm going to open this one to the side, open to side like this, okay? No, it's the wrong one. Hold on. This one, yeah, okay. So let's close this one. There we go. Okay, so over here, all we need to do is we need to introduce another lazy val, okay, like this, lazy val boundary of type boundary equals, and now we can grab these guys, put them over here, delete to be like this, and this is going to be boundary and join the lines, okay, like this, okay, so now they work, right? So just took it out, we just extract the variable, and I wish that metals could do this someday, right? Because it shouldn't be too hard, I guess. We just extracted a variable. Now, for good measure, even though we don't really need it, I really like it when things are consistent. I don't like exceptions and corner cases and so on. So what we're going to do is over here, we're going to do the same thing. Okay, so we're going to do lazy val boundary, which is a boundary equals, and we're going to grab over here these guys and paste them over here, delete to be, and over here we're going to do boundary. There we go. So now they look very, very simple. It's just that over here we see a clear dependency of this use case on that use case. Let's not forget that we also need to run this thing. So let's go to main, and we're simply going to duplicate this line, and we're going to do a report over here. Okay, and maybe let's actually grab one of these guys, put them somewhere in the middle. Okay, and at this point we can actually run this thing. I believe today we can actually run with bloop. So what is it? It is brun main. There we go. Okay, a little bit more space. Whoa, I like this. A little bit more space. Maybe a little bit less space over here so that my hyphens fit in. And actually, we probably don't need so many hyphens. Okay, like this. 50 should be good. 50, 50, 50. There we go. Let's actually continuously run it like this. Okay, there we go. False. And this is the report, so to say. As mentioned in the beginning of the video, I want to upload the whole thing to GitHub. So let's actually go and commit this thing. As of right now, we only have the initial commit that I made 6 days ago. So now let's just dump everything in there, and we're going to call it bad. Okay, so the whole thing just became part of the commit called bad. All right, so now that we have that, let's actually talk about what is wrong with this design. Okay, so the first design is sort of like an inconvenience for me. Again, is the fact that the boundary has the dependency on two things instead of one, right? Which means that when I'm going to write my test, I need to fake two things, and I really don't like this, okay? So this is just a preference, and it's very easy to remove. So the first step that we're going to do is we're going to remove it, and we're going to remove it in a slightly wrong way. However, it will move us closer to the real solution. In fact, I kind of changed my mind because I want to write the test and I want to write the main method, run the main method. So I believe it's a little bit more convenient to do via SBT. Okay, so let me launch SBT real quick. So what I want to do is I want to run the test continuously, and also when the test finish, I also want to do main run. Okay, so that's it. This is what we need, and let's see how much space it's going to require. Yeah, like this. I also want to see a little bit of green There we go, all tests pass. Okay, so this is enough. All right, so essentially what I want to have here is I want to delete this whole thing. And basically for now, I simply want to move the comparison boundary inside of the gate. Okay, again, as already mentioned, for now it's like slightly in the wrong way. We're simply going to put it there and that's it. And by the way, this thing already, like this is the violation of the law of Demeter because we have an object, right? We have an object called gate. We're calling something on inside of it, which is fine, right? It's a method, right? But this method returns us another object, right? You can never do this, right? You have an object method call. If it returns you another object, you're doing it wrong, or at least it's a violation of the law of Demeter. The law of Demeter basically says you can only call your own things or your direct neighbor. And the violation of the law of Demeter is exactly what leads you to entangled code and many, many other things. But this is one of those definitely. All right, now this is okay for now. So let's go into the gate for the report. By the way, because I'm having these consistent names everywhere and consistent packages, like I'm having all of these conventions, it's super, super easy to find. For example, let's say I want to go to the controller of comparison, right? I can use the file search or the symbol search, right? For example, I want to say, okay, I want to go to the controller. Okay, well, which one? Well, the one for comparison. There we go. Or the other way around, comparison, and then controller, right? Or the metals symbol search, right? So I'm going to say I want controller. Well, which one? Well, the one in comparison. Right, there we go. Super, super easy to find and super, super easy to jump around. I've heard that IntelliJ has some issues with this though. I'm not an IntelliJ user, so I have no idea. All right, so I'm in the correct gate, right? So this is the gate for the report. So I'm going to go over here and this is going to be another private trait. And we're going to call it has other boundaries, right? Because if we continue with this, right, we're going to have like a bunch of boundaries that are going to be the dependency of the report boundary, okay? And we're simply going to throw all of them in here. But for now, we're going to have only this one. And in fact, we're going to remove it in just a couple of minutes. Okay, so it's going to be comparison dot boundary like this, and now here we're going to say it's going to be storage comma has other boundaries like this, and over here we're going to have a convenience, right? So we're going to be able to pass in the comparison boundary, and this code will create a has other boundaries for us. Okay, so we're going to do comparison boundary comparison boundary like this. Now over here we have a name conflict, right? Because over here in this anonymous class, we would need to go over here and we would need to say override def comparison boundary, right? And if we simply do this, right, then we're gonna have a Stack Overflow, right? And over here it's not hash, it's has like this, okay? Right, so this is an infinite recursive call. We actually get help from the Scala compiler. Okay, so in order to save this, we're simply going to do val underscore comparison boundary. You can obviously call it however you want, but this is what I prefer. Boundary like this. Go to the beginning and add this tiny thing. Okay, there we go. And also let's do this like that. There we go. Now we should be already fine over here, but the diagnostics are not cleared. So let's introduce another one like this and do it like that. As you can see, it disappeared. So now I'm going to press cascade compile, and I'm going to wait a couple of seconds until a couple of errors appear over here, and then we can just press F8 and it will jump to my next issue. And this is the issue that we now move the comparison boundary into the gate. So all I need to do is this, and well, I need the comma as well. There we go. Okay, so I just simply moved it. I simply moved it up. All right, so let's look at the diff real quick. Okay, so simply removed the comparison boundary from our boundary because we moved it to the gate. And therefore, our gate contains a couple of changes, and the dependency graph has this one line that simply moved into the gate. Let's commit this real quick. We're going to call it better, like this.